Hey guys, what's up? So, once again, I welcome you back to the lecture. And in today's lecture, we will just be discussing the summary of the entire chapter that we have done till now. So, can I call this class as a master class of the entire periodic classification of elements? You will decide that thing after watching the entire recording. So, let's begin with the lecture. Okay, so the first property that I'll be talking about today is the atomic radius. As the arrow points in the downward direction, so this means that the atomic radius increases when we go from top to the bottom of the group. So this I think is an obvious thing if I'm talking about the atomic size. So how will you start? We'll say when we go down the group, then the number of shells increases. So when the number of shells increases, we can say the distance between the nucleus and the outermost shell increases. So when the distance between the nucleus and the outermost shell increases, we can simply say the atomic radius or the atomic size increases. Okay, this is what I have shown here. When you go down the group, you can simply remember that the atomic size increases. Okay, we have done one more thing, that if I go, I'm writing across the period here. So if I go across the period, so we generally do from left to right, right? So when we do across the period from left to right, we will say that the number of shells, they remain same. So if the number of shells remain same, but the number of positive and negative charges increases, so we say that the attraction between the positive and the negative increases. So the nucleus now attracts the outermost electron more strongly. So if the nucleus attracts the outermost electron more strongly, so we can say that the outermost electron comes closer to the nucleus. It comes closer to the nucleus. And if the outermost electron comes closer to the nucleus, we can say that the atomic radius, or in other words, atomic size, decreases. So when you go from left to right, atomic size decreases. In other words, I can say when I'm coming from right to left, that means there will be an increase in the atomic size. So see, the arrow says that when you come from right to the left hand side of the periodic table, the atomic size will increase. Right? So I hope these two things are clear to you. Now let us move on to the third thing, which is electronegativity. So for that, we first need to know what electronegativity is. We discussed in the previous lectures, electronegativity is the tendency to accept the shared pair or to attract the shared pair of electron towards itself. Okay, so how we define it? We say that when we go, let's do from here, when we go from left to right in the period, the number of shells remains same, the number of positive and negative increases, attraction between positive and negative increases, nucleus attracts the outermost electron more strongly. That means here, till here I can say if the nucleus attracts the outermost electron more strongly, that means the nucleus will have more share of the outermost electron, and hence the electronegativity increases. So in other words, I can say, let's go back. If I'm going from left to the right hand side of the periodic table, we have already learned that electronegativity increases. So the third point is also clear. Now let us move on to the fourth category, which is when we go down the group, the number of shells increases, distance between nucleus and outermost shell increases, atomic radius increases. So if the atomic radius increases, then I can say nucleus and outermost electron will be far away from each other, right? So this is obvious, no? When you are going from top to bottom of the period, the atomic size increases. So the nucleus is here, whereas the outermost electron is far away from the nucleus. So the nucleus won't be able to hold the outermost electron tightly. So now the outermost electron will not be held tightly, and if it cannot hold the outermost electron tightly, that means nucleus won't be able to attract the outermost electron more tightly, and hence the electronegativity decreases. So what I have said, when you go from top to the bottom, I have said electronegativity decreases. In other words, can I say when I'm going from the bottom of the periodic table to the top of periodic table, size decreases and hence electronegativity increases. So this was our fourth point. Okay. We also learned one more thing, that the metallic character. So we learned it that metallic character is the tendency to lose electrons. So when you go from top to bottom of the period, size increases and hence distance between the nucleus and outermost electron increases. Nucleus and outermost electron will be far away from each other. Nucleus will not be able to hold the outermost electron tightly. Right? So we have discussed the same things. Now if the nucleus is not able to hold the outermost electron tightly, that means outermost electron can be lost easily. So if the outermost electron is lost easily, that means the metallic character will increase. Also, I told you that the metallic oxides are basic in nature, so I can also say the basic character increases. And thus in the picture you can see I have written the metallic character will increase. So with the increase in atomic number, I can say that the metallic character also increases. Also we discussed one thing, that most of the metals will be lying here, whereas most of the non-metals will be lying here. So this is the section of non-metals, this is the section of metals, and hence I have shown in the arrow that the metallic character increases when you come to the left hand side. So more and more left hand side at the bottom you are, more will be the metallic character. If you go to the top and more on the right hand side, you will have the non-metallic character. Along with the metallic character, you can talk about the basic character, and along with the non-metallic character, you can also talk about acidic character, because we have already studied that the metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. Okay, so sometimes guys in CBSE what they do, they will draw this arrow and they will write, so suppose they have drawn this particular arrow and let's say they have drawn this particular arrow, and they'll give you two options, one is electronegativity and one is atomic size. So they'll ask you to fill up the arrows. So until and unless you know the trends, you won't be able to do questions of that particular type. So I have introduced this slide also so that you are aware of what kind of questions can be there in the CBSE exams. Okay. So guys, this was all about the chapter periodic classification of elements. So here we discussed why the need of classification was there, and then how many scientists came up to classify the elements. We studied about the Dobereiniers, we studied about the Newland, we studied about Mendeleevs. For Mendeleevs, for Dobereinier, and for all these scientists, you need to know what are the advantages and what are the disadvantages of their classification. Finally, we moved on to the modern periodic table. You also need to know what are the positions. So we have taken 2 lectures for the position of elements in the modern periodic table, how to figure out the valency, and then we discussed all these trends and their definition. So this chapter is really going to be important for those also who are taking science in class 11th. You will find this chapter once again in your syllabus. So study it well and do not forget it. Practice, and if you have any doubts, please find yourself free enough to come up to us and we'll solve your doubts. So with this note, I would like to take a leave. Thank you very much. Take care. Bye-bye.